Today we're going to be working with 2-2 skills practice, and just like I told you guys the other day, you might have a different worksheet than your partner or your neighbor, but make sure you take notes on this video, and we will work the worksheets in class on Thursday. So let me give you a few examples. If we're talking about linear equations, okay, numbers 1 through 9, and this goes for both worksheets, is going to ask you to state whether each equation is a function, each equation or function is linear, and if it's not, it wants you to explain why. So here's an example. If I have two examples here, I have 2y plus 4x equals 8, and I have x squared plus 4 equals 8. So in order to determine whether or not it is linear, what do you guys think I should do? What could I do with this first equation? Some of you are probably telling me to go ahead and solve to get y by itself, which I absolutely can do. But let's look at the equation. If I have 2y plus 4x equals 8, my y and my x are both to the first power. So do we think this equation is linear? Yes. The answer is yes, this is linear. Okay, but let's look at x squared plus 4 equals 8. If I have something that has an x squared, what is that type of equation? Is it going to be linear or something else? You should have said that my answer would be quadratic. So here, my answer is no, this is not linear, and my reasoning is that it's quadratic. Okay, that x squared makes it quadratic. A worksheet that might help you guys is if you look at the parent function worksheet that I gave you as notes. That will help you determine whether or not it's linear. Okay, so let's look at the next section. The next section asks me to write each equation in standard form. I'm going to identify the A, B, and C. Now, I know most of you didn't have a lot of practice with this because you hadn't done the characteristics of linear functions. So make sure that you write down this example. I'm going to work problem number 11. So let's look at it. Looking at problem 11, I have 2x equals 7 minus 4y. Now, in pink, I have the standard equation. It's ax plus by equals c. Now, what I had told you guys in your notes was two things specific about a. Can anyone tell me what they were? The first one was that it had to be a positive number. A had to be positive. And the second one was that I could not have fractions. So there were no fractions. Now, this only has to be part of A. My B and C can be positive or negative as well. So let's look at the example. The first thing I want you to do, step number 1, is going to be to get it in the correct order. So I know that I have an x has to be first, then my y, and the number, which is c, or my constant. So here's how we're going to work the order. If I have this negative 4y, and I need to move it to the other side. If it's minus, how do I move it to the other side? That's right, I'm going to add it. So what I should have is 2x plus 4y equals 7. So based on my information, my x and my y are in the right side, or excuse me, are on the left side of the equation, and my constant c is on the right-hand side of the equation. So now that the order is correct, my second step is to make sure that A is correct. And what I mean by that is to make sure that I have a positive number and to also make sure that there are no fractions. So let's look at A. What number is A in this equation? It's 2. Is 2 positive? Yes. And is 2 a fraction? No. So since it passes both of those steps, that is my answer. I'm done with standard form on this problem. Okay, so let's look at another example. The last section that I have is asking me to find the x-intercept and the y-intercept of the graph of each equation, and then it wants me to graph the equation. So let's take number 15 for example. So I have y equals 3x minus 6. Now remember, when I'm looking for an x and a y-intercept, again, on that same packet of notes, I told you that we should plug in a 0 for x to get my y-intercept and a 0 for y to get my x-intercept. So look how this would work. If we want to find our x-intercept first, I'm going to plug in a 0 for y. So here's how that one would work. I'd have 0 equals 3x minus 6. And then the next step is going to be to solve for x. So here I'm going to add 6 to both sides. I have 6 equals 3x. Divide both sides by 3. X is equal to 2. So how would I write my x-intercept? That's right. I would have 2, 0. So there's my x-intercept. So what happens if I'm looking for my y-intercept? With my y-intercept, I'm going to plug in a 0 for x, and then I'm going to solve for y. So here I have y equals 3 times 0 minus 6. So I have y is equal to 0 minus 6, and 0 minus 6 is just negative 6. So y is equal to negative 6. So how would I write that as a coordinate point? That's right, 0, negative 6. So that's how I find the x and the y-intercept. Now what I'm going to do in order to graph them is I'm going to plot both the x and the y-intercept, and then I'm going to connect the points. So let's look at the graph. So using the x-intercept of 2, 0 and my y-intercept of 0, negative 6, let's plot both points. So here, I'm going to go to the right 2, and I put a point. And then I'm going to go down to negative 6 and put a point as well. Now that I have both x and y-intercept on the graph, all I have to do is connect the dots. I know that's a little bit off, but I'm just going to connect the dots. So you're going to do the same thing 16, 17, and 18. Again, we will finish this in class on Thursday. If you guys have any questions, please let me know.